Hello students, welcome back with one of the vital and interesting problem on the topic on reflection of light for the combination of spherical mirror. Here I am going to discuss. I hope it will guide you in solving various problems based on the concept using the mirror formula, which is 1 by V plus 1 by E is equal to 1 by F, and your student is already derived, it is already explained vividly how the mirror formula is 1 by V plus 1 by E equal to 1 by F, and all of you know. Once again you can go through and you see uh, you can understand the mechanism of the concept, the derivation of the mirror formula, which is 1 by V plus 1 by E equal to 1 by F, and here in this class I am going to discuss and the problem based on the formula 1 by V plus 1 by E equal to 1 by F, okay, for the combination of the both the spherical mirror, convex mirror and concave mirror, right? Okay, so here is me, Makan Sausar for you. Yes, discussing a problem based on the ray optics. Here is the problem. Look at once again, read out the problem. Here you see an object is placed exactly midway between a concave mirror of radius of curvature 40 cm and a convex mirror, the radius of curvature is 30 cm, right? And the two mirrors face to each other and 50 cm apart. The distance between the two mirrors is 50 cm apart. Okay, they face to each other. Determine the nature and the position of the image formed by the successive reflections. First are the concave mirror, then are the convex mirror. Okay, understand? Let's see. This is one of the vital problem and interesting problem based on the mirror formula. Okay, which is most important for you, and in many examination you will find such kind of problem. Okay, let's see. So here is the diagram for the mirror formula. Look at here. Here is the two mirrors are there face to each other. One is the mirror is the concave mirror. This is the concave mirror, and this is the convex mirror, right? Yes. And the distance, see here. Okay. Yes. So here you have to find the nature and position of the image due to first concave mirror and by the convex mirror. Okay. And you see here, here AB is the object. You see now, this is this is which mirror? This is the concave mirror, right? And this is the convex mirror, and the distance in the two mirror is what? 50 centimeter distance, right? Yes. Okay. Look at here. Here AB is the object. Here AB is the object. Here AB is the object, which is placed in the midway at the position B, and B is the midpoint between the two mirrors. And you see the distance between the two mirrors is what? Is 50 centimeter, right? Here you see the distance the two mirror is 50 centimeter, and the object is placed in the midway between the mirror and in front of the concave mirror. So AB is the object, okay, and the radius of curvature of the concave mirror. What is the radius of curvature of the concave mirror? Yes, tell. This is R1 is equal to 40 centimeter. Okay, and the radius of curvature of the convex mirror, which is R2 is equal to 30 centimeter, right? And the distance in the two mirror is P1, P2, which is 50 centimeter. Look at here. This is the distance of the two mirror is 50, P1, P2 is 50 centimeter. And the, okay, understand, since the object is placed in the midway, so since AB is the object, so the object will be situated at the distance of 25 centimeter in front of the concave mirror. Yes or no? Yes. And this is the distance of the object from the concave mirror. Yes. Understand? Okay. And you see now the radius of curvature of the concave mirror is 40 centimeter and the focal length is what? 20 centimeter. Yes or no? Yes. You see here the radius of curvature of the convex mirror is 30 centimeter. Okay, so focal length will be what? 15 centimeter naturally, right? Let's see. Look at. So here once again see clearly AB is the object. AB is the object placed in front of the concave mirror, right? And the radius of curvature of the concave mirror is R1. As per the question is 40 centimeter, right? This is the radius of curvature of the concave mirror. And radius of curvature of the convex mirror is what is that? R2, which is 30 centimeter. Yes or no? And the distance between the two mirror, is what? P1, P2 is 50 centimeter apart, right? And this is the distance of the two mirror is 50 centimeter apart. Okay, understand? Let's see. So the object is placed, you see now, see, the object is placed midway between the two mirror. Okay, so the position of the object from the first concave mirror is a distance of 25 centimeter because the midway. So you see this is the at the position B, the object is placed at the position B, and which is the midway between the two mirrors. Okay, so if the distance in the two mirror P1, P2 is what? 50 centimeter, so the object is situated at 25 centimeter distance from the concave mirror. Okay, understand? Is it clear? Understand? Yes? Okay, yes. So look at here once again. Oh, okay, here A dash B dash. If you see now, this is the concave mirror, and the object is placed at the position was AB is the object. AB is the object, right? AB is the object. Okay, and the distance the object for the concave mirror distance the object is U1, which is minus 25 centimeter. Why it is minus 1? Already you know. As per the sign convention, here the object AB is situated to the left of the mirror, to the left side of the pole P1. So any object is placed to the left side of the pole of the mirror. So this it is taken already as per the sign convention. It is always taken as negative sign. Since the object is situated is placed to the left side of the pole P1. Okay, understand or not? So distance of the object is E1, which is negative sign, which is minus 25 centimeter. Similarly, the focal length is also to the left side of the pole P1 of the concave mirror. That's why since radius of curvature is 40 centimeter, so focal length is minus 20 centimeter, which is negative sign. So for the mirror formula, you know, using the mirror formula 1 by U plus 1 by V is equal to 1 by E1 plus 1 by V1 is equal to 1 by F1. Yes, understand? And E1 is the object placed in front of the concave mirror, which is heavy. Distance the object, and V1 is the distance the image, and F1 is the focal length of the concave mirror. So 1 by V1 is equal to 1 by F1 minus 1 by E1. This 1 by E1 will be transposed to the right hand side. Understand? So it will be 1 by V1 is equal to 1 by F1 is equal to 1 by E1. Right? Once again see. Okay. So 1 by V1 is equal to 1 by F1 minus 1 by E1. So 1 by V1 is equal to 1 by, what is the value of F1? F1 given how much? Minus 20 centimeter. So here you can use the value in place of F1 minus 20. And here the distance of the object is minus 25 cm. So here distance of the object is minus 25 since minus sign. So you have to write within the bracket. Bracket must be given. Okay. So now you see minus 1 by 20 minus or minus 1 by 25. It will be minus 1 by, you will add this one by taking the mathematical process. All of you know how to simplify it. Yes. Yes. Okay. You see now. Here you see. This is F1 value is minus 1 by 20. E1 value is minus 1 by, this is minus 25. Okay, so in place of F1 and E1, you use the value, you get after simplification, it is minus 1 by 20, and this is, you see minus and minus. This is minus and minus. It will be 1 plus 1 by 25, which is minus 1 by 100. So you see now 1 by V1 is equal to minus 1 by 100. So V1 will be minus 100 centimeter. This is a mathematical process. So you can find out the distance, the image, which is 100 centimeter, which is negative. It means the image is found to the left side of the pole of the concave mirror. Right? Understand? Okay. Let's see now. Look at here. See here, see. Now the nature of the image by the concave mirror is V1. Yes. Which is, what is the value of V1? The V1 is minus 100 centimeter, which is negative. So the image is A dash B dash is the image of the object for the concave mirror, which is real, inverted. Yes. And the image is found at 100 centimeter away from the concave mirror. Right? Understand? Here you see this is the image. A dash B dash is the image found, which is inverted, real, and okay, and which is placed at 100 centimeter away from the concave mirror to the left side of the pole. Right? Understand? Okay. Now say for the convex mirror. Now you see there is another mirror, which is the, and this is the which mirror? Convex mirror. And here for the convex mirror, and you see A dash B dash is the what? Object. For the convex mirror, A dash B dash is the object. Understand? And the distance of the object from the convex mirror is what? What is the distance of the object from the convex mirror? Tell. Yes. This is the distance of the object from the convex mirror, which is, you see, which is P1 B dash, which is P1 B dash, P1 B dash, and which is minus what? P1 P2, minus P1 P2, minus P1 P2, right? So this is P1 B dash minus P1 P2, which is 100 minus 50, which is 50 centimeter. Okay, so the distance of the object here, A dash B dash, it behaves like the object for the convex mirror, and which is situated at 50 centimeter away from the convex mirror. Is it clear? Understand? Yes? Is it clear? Once again see. Look at here, and this is the image of the concave mirror A dash B dash, which is 100 centimeter away from the concave mirror P1 B dash. Yes. Now see, and this for the this image A dash B dash is the object for the convex mirror. Okay, understand? Which is situated a distance of P to B dash. P to B dash. What is P to B dash? The P to B dash is P1 B dash minus P1 P2. P1 P1 B dash. P1 B dash minus P1 B2, and then you will get, okay, and this is the distance of the object A dash B dash will be situated, which is behaves like an object for the convex mirror, is situated at, okay, 50 centimeter away from the convex mirror P2, right? Now you know radius of curvature. What is the radius of curvature? The radius of curvature is R2, which is 30 centimeter of the convex mirror. So focal length will be 15 centimeter, half of the radius of curvature. Again you have to use the mirror formula 1 by U2 plus 1 by V2 is equal to 1 by F2. Yes. So 1 by V2 is equal to 1 by F2 minus 1 by U2. So you can, okay. So here U2 will be transposed to the right hand side. Understand? Yes. So it will be 1 by F2 minus 1 by U2 is mathematical process. So by using the value 1 by, okay, you see now F2 value, what you see now? 1 by V2 is equal to 1 by F2 minus 1 by U2. Right? Yes. So 1 by F2 value what? 1 by 15. You see 1 by 15 minus the value of U2 is already 50 centimeter. Okay. This is 50 centimeter already used. Okay. So after calculation we will get 7 by 150. It means 1 by V2 is equal to 1 by 7 by 150. So V2 is equal to 150 by 7. Hence after finding the value, so V2 is equal to 21 by 21.43 centimeter. And this is the final image which is found, okay, at a distance 21 centimeter, 21.43 centimeter from the convex mirror, right? Yes. Look at here. So since V2 value is positive, so the image found at the distance 21.43 centimeter from the convex mirror. Since it is positive, the image is found between the focal length and the center of curvature C2 of the convex mirror, and which is erect and virtual. Because the image is positive, distance image is positive, so image is positive and behind the mirror. Okay, understand? This is the nature of the image found by the combination of the mirror. Okay, when object is placed between the midway between the two mirror, one is the concave mirror, other is the convex mirror. Okay, understand? So this is a very simple and very interesting problem for you, and which you will find. So you see, as the V2 is positive, so the image is found a distance of 21.42 centimeter from the convex mirror. The image is found between F2 and C2, and which is erect and virtual and found behind the mirror. Right? Yes. Okay. Thank you for watching the class, and I hope you will solve the different kind of problem based on the concept. Okay. Thank you, all of you.